So yesterday we discussed first how to write MapReduce application, right? So we discussed Eclipse project creation, and next we discussed what are different archetypes are available in Maven, and next we discussed uh, we created three classes. Then we added required jar files to pom.xml file. Next we discussed why Hadoop data types. Why Hadoop data types? Next, we started discussing word count mapper class, right? Next, let's start discussing user defined word count reducer class. Word count reducer class. I'm seeing some new people. You may not understand uh, this class. Yep, they'll send today. So every user defined class, first important point, every user defined reducer class, user defined reducer class is a child class of is a child class of let me open Eclipse. So every user defined reducer class is a child class of org.apache.mapreduce.reducer class. Every user defined reducer class is a child class of org.apache.mapreduce.reducer class. Reducer class. Yep. And 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 it must override it must override it must override reduce reduce function. It must override reduce function. Yep. So processing logic is executed by task tracker or node manager. See why mapper class and reducer class must extend our word count mapper class must extend mapper class, right? And it must override map function. Yes or no? It must override map function. And inside this map function, we write custom logic. Custom logic. Based on our requirement, we write custom logic. Same as we are saying word count reducer class. Word count reducer class must extends reducer class. Reducer class, and it must override reduce function. It must override. Yep, word count reducer. I'll correct it. So we write custom logic. Custom logic. So see why it is mandatory to override extend mapper class and override reduce function map function. Why it is required to extend reducer class, and why it is required to override reduce function. But we are writing logic here, right? Whatever the logic we are writing, this logic is going to execute. Yep. Yep. But predefined class we are not using, right? But why it is required to extend mapper class? First one, remember one point. So these classes, this method is called by whom? Are we calling anywhere? We are writing driver class. We are writing driver class. In driver class, we are specifying which is mapper class, which is mapper class, and which is reducer class, and where is input path, input path, and where to write output path, and next we are saying input input key and output key. Let me show you the code. Input key and output key. We define only these details. Output key. We define only these details in driver class. We cannot say call map function, call reduce function. We cannot say anything in this driver class. But our Hadoop is going to call corresponding methods. It may be single cluster, it may be multi-node cluster. Internally, this reduce function and map function, mapper logic and reduce logic is executed by Hadoop, right? These logics are going to execute by Hadoop. It may be single node cluster, it may be multi-node cluster. Finally, this map and reduce function, reduce logics are executed by our slave machines, right? So how? So we are not calling these methods. These methods are automatically calling by Hadoop cluster or Hadoop mission, right? So how, if I write like this, word count, word count, and if I write map function, and if I submit this one, here also I am implementing required logic. Assume I am implementing required logic only. But if I submit this program, to Hadoop cluster, our Hadoop cluster cannot understand. Even though this class contain map method, but this class cannot understand this word count class. But if you submit this class to Hadoop, then it will understand. This class will understand. Hadoop can understand this class, but Hadoop cannot understand this class. So if you are a Java programmer, you will get a clear idea why this class is not understanding by Hadoop. This class, why Hadoop understanding this class. See, in Hadoop we have, so who is going to execute this one? Hadoop, right? Hadoop is going to create object of our class, right? We are not creating object of our class. We are saying in driver class saying this is word count mapper class. Then Hadoop is going to create, if data is available here, it is going to create a map object here. If data is available here, and object is going to create in this location, right? So assume we have a file 1, File 1 contains 3 blocks, replication is 1. So we have 3 blocks. So map instance is created here. Map instance is created here and here and here, right? Are we creating object in these locations? No. We are submitting our program to Hadoop. Hadoop is going to create object. So Hadoop internally has logic to create. If your class, first it will check, Hadoop checks your class is child class of mapper class. Your class is child class of mapper class. Yes, our class is child class of mapper class. First Hadoop will check, first it will check relation. First it will check this relation. Extends means parent to child relation. It will check parent to child relation. Yes, your class is child class of mapper class. Here it will check your class is child class of mapper class. No. Then first statement is failed here. And why it is checking internally your class is child class or not means there is one concept here. There is one concept. Uh, Parent class reference equal to parent class reference equal to child class object. Child class object. I think this concept may be available in all object oriented language. So parent class reference equal to child class object. Maybe some people not covered. So this concept is available in all object oriented languages. This is not specific to Java. Okay. So here parent class is mapper, right? Mapper m equal to new. Child class may be word count, child class may be xyz, child class may be anything. So it will create child class object. Child class object. Then it will call m dot map function. Here it will create object in this location. It will call map function. Map function, it will pass this block to map function. Here it will pass this block to map function. Here it will pass this block to map function. Then whatever the logic we written inside map function, it will execute. So this concept, internally it will create this concept. So mapper class has only map function, right? That's why it call only map function. If you write any other functions here, if you write instead of map function, if you write Srinivas function, our Hadoop cannot understand what is this Srinivas. It knows only map function because Hadoop internal implementation, they implemented mapper class. So Hadoop understand only mapper class. So Hadoop knows only mapper class methods. That's why it called m.map function, not our methods, our own methods. That's why while explaining, I'm clearly saying override reduce function, override map function. Okay, override reduce function and override map function. Why we are overriding only reduce function? Why we are overriding map function means Hadoop understands only these methods, these functions. Okay. And one more point I'm clearly giving. One more point is how Hadoop knows about our class. Here I said it is creating our class, right? It is creating syntax like this: new word count. It is using our class name. Hadoop is developed some years back, 5 years or 7 years back. But just now we written class. How Hadoop understands our class? It is internally creates this syntax only. Mapper m equal to Hadoop knows this syntax up to this syntax. But how Hadoop knows about this syntax? There is one special concept in Java, reflection. reflection API. There is one special concept in Java called reflection API. By using this API, here we submit a dot class file to our Hadoop application, right? It will read that dot class file by using reflection API. By using reflection API, it will do, in Java we do postmortem. Postmortem means by using this reflection API, we can find what is class name, what is parent class name, what are the methods presented in class, and what are the variables declared inside a class, what are constructors available in the class. We can find everything by using reflection API. Maybe most of the people don't cover this reflection API in Java classes. So it uses this reflection. It uses this reflection API to know your dot class file, and it uses different methods presented in this reflection API to know class name, to know members, to know methods, constructors, everything. By using this reflection API, it reads our class and understand whether your class is child class of mapper class or not, whether your class contain map function or not. Then once it creates object, right, it will call map function by passing this data. Okay, so that's why it is highly recommended to override reduce function, because we are not calling this function, it is calling by Hadoop. That's why we have to write a reduce function in reducer class, our reducer class. It is highly recommended to override, not recommended, it is mandatory to override reduce function. Okay, next, see reduce function, reducer class. In reducer class output is assume reducer class instance. Let me write one important note here. So in interviews, they may ask one question like, how many mappers are created? How many mapper instances are created? Instances are created. How many mapper instances are created? So this is based on based on number of number of unique blocks of unique blocks of file. Example, file is 300 MB. 300 MB. How many unique blocks are presented for this file? 3 unique blocks, right? 3 unique blocks. So 3 mapper instances. 3 mapper instances. 3 mapper instances are created. 3 mapper instances are created. Depends upon the blocks. Here clearly saying, right? If file has 3 blocks, 3 unique blocks, so 3 mappers are created. Then same question, how many reducer instances are created? Reducer instances are created. 3. Sure. So what is the input for reducer? Mapper or mapper output? Mapper output, right? So after processing result may be very less, right? From block 1, maybe we got 1 KB or 1 MB. After processing 128 MB, result may be 1 MB. For after processing second block, result may be 1 MB. Here after processing, result may be 1 MB. Total output of all mappers is 3 MB. So is it creates 3 mapper, 3 reducers? No. So it is depends upon mapper output. It depends upon, it is depends upon mapper, all mappers, all mappers output size, output output size. If size is less than or equal to 128 MB, less than or equal to 128 MB, it will instantiate one reducer. If size is greater than 128 MB, for every 128 MB, for every 128 MB, it will create one reducer. It will create one reducer. For every 128 MB, it will create one reducer. It depends upon the it depends upon the mapper output size. So your reducer may be started in any one mission. So it passes all mapper output to reducer location. So the intermediate result, this mapper generates some result, right? So it is generated some result. So this mapper output, all mappers output goes to reducer location. Here reducer 1 is started. So all mappers output travel to reducer location. Okay. So finally this reducer process this mappers output and finally it will store into HDFS location. So until reducer process this data, all the data in local memory only, local file system. Okay. So inside reducer, it will call reduce function. Inside reducer, it will call reduce function. So this is reduce function. So before going to call reducer function, so assume this is our output of mapper, output of mapper. So we have let me take continuation of this one. We have two right, two lines, two lines. So this is second line. For second line also it will create a array for this one. So MapReduce is a big data processing engine. Then it is created MapReduce, comma 1. Next one is comma 1. Next a comma 1. Next big data comma 1. Next processing comma 1. Processing comma 1. Next engine comma 1. Engine comma 1. So after completing this complete mapper, so this is the output of mapper. This will become input to reducer, right? This will become input to reducer. So here, what reducer is doing? Reducer first performing three operations: grouping operation, sorting operation, next aggregation operation. Aggregation operation implementation we written here in reduce function. Before aggregation operation, it will perform two operations: grouping operation. So in this grouping operation, it will create map object. In this map object, it performs key and value. Value is a list. Value is a list. So first key is what? This is multi-line comment. First key is Hadoop and value is 1. It creates in a list. Next key is and value is 1. Next key is A. Value is 1. Next key is big data, right? Big data. Big data value is 1. Next key is so Hadoop is a big data framework, right? So we copied multi-line. So let me copy actual one. So Hadoop is a big data framework. And MapReduce is a processing engine. So this is the output of mapper. Okay. So it is performing grouping operation. In this grouping operation, so is a big data. Next one, framework 1. Next one, MapReduce. Key is a MapReduce. Value is 1. Next one is key is already available. If key is already available, it will append value to value list. Value to value list. Next, A key is already available, so it will append value to value list. Next, big data is already available, so it will append value to value list. Then next, processing is key is not available, so it will create a new key and value to value list. So engine is not already available, it will enter engine and next it enter value to value list. So grouping phase is completed. Next one, it performs what? Sorting phase. Sorting phase. In sorting phase, it arranges this data. It arranges this data. Let's see what will happen in aggregation phase. So it will arranges this data. First one is A. Next one. Next one is big data, right? Next one. Next one. Framework. Next one. Next one. H. HI or engine. IH or HI? G? Okay, this is correct, right? Next. So this is the, in this way it will arrange data in sorted order. Next it will call aggregation phase. After arranging this one, it will call reduce function. Each time it will read key value pair and passes this key value pair to reduce function. So key is passed to this one, value is passed to this iterable list. Iterable is used to navigate any list in Hadoop collection. Hadoop collection, to iterate values one by one, we use iterable class in Java. So we are passing this key, this entire key. First it will read one key value pair from map object and it call reduce function. How many key value pairs are available? Those many times this reduce function will call. How many key value pairs are available in your sorted map object? Those many times this reduce function will call. So first it will pass A to K and this value to this iterable list. Then from iterable list contain list of integer values, right? Iterable data. What I am doing, this is for each loop. In this for each loop, I am reading first value. So for each loop reads first value and loads into this variable. For each loop reads this value and stores into in this variable. Let me explain one more clearly. So I have a array with 1 comma 2 comma 3 comma 4. So I am writing for each loop int I colon a, int I colon a. So what I am doing here, int t equal to 0. So what I am doing, each time it will read first value and stores into I. Each time it will read, this is array, right? From this array it will read value and stores into I. Then what I am doing, t equal to t plus I. So first time we are reading 1 and we are adding to t. 0 plus 1, 1. We are adding, we are assigning into t. Next iteration it will read second value. So t now it has 1, right? 1 plus 2, 3. We are storing into 3. Next iteration it read next value and we are adding into t. 3 plus 3, 6. Next iteration it will read 4 and assigns to I. Then 6 plus 4, 10. So in this way, here for each loop reads each value from this list. First it will read 1. So this is in writable format, right? To convert writable format to integer format, every writable class contain get function to convert corresponding data type format. So we are converting writable format to integer form. Then 0 plus 1 we are adding to total. Next iteration it will read second value and 1 plus 1, 2. There is no other value, so it will comes out from for each loop and we are writing key is already in text writable form. What is that key? A, and we are total is in integer form, right? So integer form to we are converting into writable form. Finally we want to write into HDFS file system, right? So we are converting 2 into writable form and we are writing into context. This context internally writes into HDFS file system. Okay, so it will write a 2. Next time this method is automatically called by passing another key value pair. Are we calling this reduce function? No. Who is calling this reduce function? Hadoop is calling this reduce function number of key value pairs presented in your map object. So if any function calls automatically in Java, if any function calls automatically in Java, I didn't remember that name. So there are, so this function automatically calling, this reduce function is automatically calling by Hadoop environment based on number of key value pairs presented in your map object. Okay. So we completed reducer class and we completed mapper class, and let's check driver class. So in driver class, first any MapReduce class, we create two objects. First configuration object. In this configuration object, we specify Hadoop configuration information. Hadoop configuration information, and this is, we create a job class. For job class, we pass configuration object. Configuration object. What is this configuration class means? This configuration class object reads configuration information, HDFS file system information, name node information, job tracker information, everything it will read and passes that object to configure, passing this configuration object to job. Then we are giving name to job. So what is the purpose of giving this name is, once we submit MapReduce application, we can open job tracker URL or resource manager URL. Once we submit, Hadoop job, we can monitor, job status, job status. We can monitor job status by opening job tracker, or resource manager, URL. So there are multiple jobs running in this resource manager or job tracker URL. So if you multiple people submitting multiple jobs, right? So multiple jobs are running in this URL. So how do we identify our job means, every job we give some name. By using this name, we can identify our job name and we can identify what is the process, what is the status of this job. Next, we are specifying driver class name and we are specifying reducer mapper class name and we are specifying reducer class name. Next, we are specifying what is the output key and what is the output value. So if you observe reducer output key type is text write and reducer output value type is int writable. So we are saying output key is text writable, output value type is int writable. Next, we are defining input path. Command line argument. This is main method. Command line argument, we pass input path and output path. And we are passing input path and output path. There is one predefined class, file input format. For this one, we are passing job input path. What this file input format class will do, this class reads this input path and passes this input path to job. Job contain mapper reducer. So this job is submitted to Hadoop. Hadoop reads this job, identifies mapper class name and reducer class name. It identifies mapper class and number of blocks, based on number of blocks, it will create mapper objects and calls map function. Okay. So then after completing map function, it will call reduce function. Reduce function generates output right? Generates outputs. It will route output into where? In configuration object, right? In context object. Then whatever the output written in this context is going to write into this output path. So context path, right? That context path contain this output location. So if reducer is writing in context path means internally it is going to write into this output location. These input path, output path we are passing through command line arguments. Through command line arguments. So we implemented reducer class, we implemented mapper class, we implemented reducer class, and we implemented driver class. Driver class. So steps, first step one, step 3 is writing MapReduce application, right? MapReduce application, we written all this. So next step 4, convert convert MapReduce MapReduce application into jar file. Convert MapReduce application into jar file. We added this dependency in previous class. We discussed in previous class. Let me show you that step. So we added this is step 4. So step 5 is convert MapReduce application into application jar file. So here, if you observe pom.xml file, if you observe pom.xml file, go to pom.xml file, go to pom.xml file. Why it is showing here? Because of Java 1.5. It is connected to Java 1.8 only, but it is showing Java 1.5. So how to resolve this error means go to window, go to preferences. Here type Java. Let's come down. Here click on install JREs. It is pointing to only JRE path. Let's click on add. Already we discussed this one. Click on standard VM and go to directory. Go to Java installation location. My Java is installed in C drive. Under C drive program files. Under program files Java. So here it is pointing JRE location. Replace JRE location with JDK. Click on JDK. Click OK. Click finish. Select this one JDK and click on apply. Click on apply and close. So next right click on this one. Here we have Maven update project and select force to update project. Click OK. So error is gone. So now it is pointing. But here we are not seeing any error. If you observe here, we are not seeing any error. It won't create any problem. Let's leave it as it is. Next, here if you see package type jar file. Marvin is creating jar file automatically with name, artifact with version. MapReduce app hyphen 0.0.1 hyphen snapshot dot jar file. It will create MapReduce app hyphen 0.0.1 hyphen snapshot dot jar file. So currently target folder doesn't have any data. Let me open this project location properties. So this is in this location, right? So this is the location. Go to this location, go to target. Currently there is no jar file. So to generate a jar file, what we will do, right click on this one. Here you will see run. Here you will see different options: build, build, clean, install, test. Clean means Maven clean means it clears already previously compiled files. Next one, install means it will compile .class files and generates jar file. So we can combine these two steps in build. Click on Maven build and here write goal. I want to clean previously compiled files and I want to install means compile and create a package. So we are doing two steps in build and click on apply, click on run. Then here you will see if any dependencies are required, it will download the dependencies. Next compiles our programs and generates jar file. Let's open here. You will see MapReduce hyphen 0.0.1 hyphen snapshot jar file, executable jar file. Take this jar file and start Hadoop, start Hadoop. Next step, step 6. Let me finish this program. So may take 5 or 10 minutes max. Step 6, submit Hadoop job. Submit Hadoop job. So it require input path, right? So to submit this one, we require input path, input path. So input path, I am creating one file. So in Linux, I am creating one file, cat greater than comment. I am writing Hadoop is a big data framework. Big data framework. MapReduce is a big data processing engine. Big data processing engine. Next one, B, input path, right? So this is local file, and to place this local file into input path location. So for this one we are using Hadoop FS. So before this I am creating our directory. So Hadoop FS hyphen mkdir slash root MapReduce. I am writing MapReduce. Under MapReduce I am going to put our local file. What is our local file name? Comment. I want to place this file into MapReduce. So input path is available. Input path is available. So next step, B, submitting job. So Hadoop, Hadoop jar, Hadoop jar, our jar file name. What is our jar file name? So it is created jar file with this name, right? It is created jar file with this name, right? Dot jar. And we need to pass input path and output path location. So before passing input path location, first parameter pass driver class name. Com dot qt dot, what is our driver class name? Com dot qt dot MapReduce app dot word count driver. So parameter is com dot qt dot, you can use in this way, slash means next line, slash means next line. So I'm using class name, driver class name dot word count driver, and slash input path location is slash MapReduce, file name is comment. This is input path. Next, output path. Under MapReduce, create WC output. So this is input path, this is input path, this is output path. Here I am writing submitting job. Submitting job. Yep, WC output is output path. So here I am writing one note. Output output directory should not be exist. Output directory should not be exist. So this output directory created by our MapReduce application, it will create. We pass output path, this path, but this directory should not be exist. This one is automatically created. In this directory, it will write output files. In this directory, it will write output files. So let's copy this file, and go to Cloudera. Paste. So this is our MapReduce application. Let's make full screen. Open terminal. Sorry. CD desktop. ls. Here we have MapReduce-snapshot.jar file, right? Next, Hadoop. Before that, we need input file. Let me open. I think we already created input file. Hadoop name node, utilities, browse file system. Here I think we created Qt Hadoop. We have a file 1, right? I want to see what is the data presented in file 1. Hadoop fs -cat under root Qt Hadoop slash file 1. So just small data, instead of that one write file So cat greater than comment and copy this data to save and come out from cat prompt control D. Next Hadoop fs hyphen put and under root under qt Hadoop. Oh, we did mistake. Here we need to pass file. So let's list files and directories. ls. So we have two files, comment file and file 1. So we are passing comment file. So let's run our application. Hadoop fs, sorry, Hadoop jar, and what is our jar name? MapReduce application, right? MapReduce hyphen 0.0.1 hyphen snapshot dot jar slash. To continue next line. So input class name is driver class name. Com dot MapReduce dot word counter driver. Next input path is 1 minute. So we use this class. So we use input path is under root under qt Hadoop. File name is comment slash. Next line under root under qt Hadoop create wc output. So this directory is not existed, right? WC directory is not executed, not existed. Once this program successfully completed, we see WC output directory. Let's press enter. So it is started MapReduce application. It is started MapReduce application. Let's open resource manager URL. You will see job. So job name is word counter. By using this name, we can identify. So it is in queue. Click on this application. It will give complete information about this job. Let's see here. Already completed. So if you observe status here, start time, finish time is completed already. Okay, let's open this one. So observe some information of MapReduce application 4. So number of bytes, total our file size bytes is 143 bytes. So how many reducers are created? Mappers are created? It is bytes, less than 128 MB. So after completing mapper process, it is less than or equal to this size only, right? So it is created reducer task is 1. Next, mapper input lines are records are 2 lines, right? So after dividing this data contain how many words? 11 words. So that 11 words byte size 11 words as passed as the input to reducer. Reducer input records are 11. In that after grouping, in that 11 words after grouping, we see 8 words because 4 words are repeated, 3 words are repeated. Is repeated, A is repeated, big data is repeated. So after grouping, we see 8 records. Next, let's go to name node URL, go to utilities, browse file system, Qt Hadoop. It is created WC output. Under WC output, you will see underscore success or underscore failure. Underscore success or underscore failure. If MapReduce application is success, we see underscore success. If MapReduce application is failed, we will see under output directory, we see underscore failure. And we see one more file, result file, part-r-5 zeros. To see the results. This is C step in step 5. If job is success or failure, instead of this one, in output directory, we see two files. One underscore success or underscore failure. So if MapReduce is success, we see underscore success. If MapReduce is fail, we see underscore failure. Second one, part-r-5 zeros or part-m-5 zeros. If result is generated, if result is generated by mapper, output result is generated by mapper, we see part-m-5 zeros. If result is generated by reducer, we see output file is part-r-5 zeros. So we write a command Hadoop space fs space -cat under root under Qt Hadoop slash mr wc output, right? Wc output slash part-r-5 zeros. By typing this command, we see the output of this file. Okay, let's execute this command. So A is repeated 2 times, big data is repeated 2 times, engine is repeated 1 time, framework is repeated 1 time, Hadoop is repeated 1 time, ease is repeated 2 times, MapReduce is repeated 1 time, processing is repeated 1 time. So this is the output of MapReduce application. Okay. So that's it for today, and tomorrow we have a workshop from 11:15 to 1:15 Hadoop development continuation. Okay, tomorrow we'll first see pig and next we start hive. So tomorrow and day after tomorrow, both Saturday and Sunday we'll discuss pig and hive. Tomorrow we'll finish first in 1 hour. We'll finish pig. Next we'll start hive. Okay. Tomorrow we'll discuss drawbacks of MapReduce program. Then we discuss advantages of pig, and we discuss both MapReduce and pig disadvantages. Then we discuss hive. We spend hive more time on hive. Okay. Yep. So tomorrow we'll meet at 11:15. That's what I'm saying. Yep. Okay. We'll continue tomorrow.